This video is for the properties of rectangles notes. So a rectangle is a parallelogram with 4 right angles. So it's a parallelogram, but we have a more specific name for it because of those right angles. And so this one would be rectangle ABCD. ABCD. All right, properties of these. So the basic properties, all 4 angles are right angles. Opposite sides are parallel and they're congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. So all of those properties from the parallelograms are the same for the rectangle. So here's where things start to change. Diagonal length. Find the lengths of the diagonal of a rectangle that has a length of 33 and a width of 8. Round your answers to the nearest 10th. So if we've got a rectangle, okay, that has a length of 33 and a width of 8, it says find the length of the diagonal. This would be the diagonal. So what happens is we form a right triangle, and so these are the legs and the diagonal forms the hypotenuse. So we can use Pythagorean theorem to do this. So what we do, since we have both legs, we do square root and then we take both legs and we square them and subtract them underneath. Okay, and this is round to the nearest 10th, which means we can just type this whole thing, 33 squared minus 8 squared, in the calculator, and that would round. Ooh, I got something different the last time I did that. That's okay. This would be 32 and then 0.0. That would be its length. Okay, so here we have another one that's exactly the same, length of 23, width of 13. So again, those are going to be the legs. Okay, if it gives you the diagonal length, we do something a little bit different. Oh, so this one does. This one has a diagonal length of 23. So again, if we have our rectangle here, so the diagonal length is 23 and the width is 13. So I still have that right triangle, but this time I'm missing a leg. So if we're missing a leg, we subtract. So we would do the square root of 23 squared minus 13 squared. And we get, if we round this one, we get, this one will go ahead and round up to 19. Okay. All right. So more about the diagonals here. So if a parallelogram is a rectangle, then its diagonals are congruent, meaning they're going to measure the same thing. So in triangle ABCD, AC is going to be congruent with BD. So AC is congruent to BD. And then they bisect, which means all the segments. So from A to O, that's congruent with O to C. A to O is congruent with O to C. B to O is going to be congruent with O to D. B to O is going to be congruent with O to D. And then also, from A to O is going to be congruent with B to O. A to O is congruent with B to O. And then the same, we could keep going. A to O is going to be congruent with O to D. So there are many comparisons. This is not all of them, right? Because A to O is congruent, or B to O is congruent with O to C. So it keeps going. There's many comparisons there. All right, diagonal length. Solve for x, then find the length of the diagonal. So this says from O to P, so that's this distance here, is 67 plus 10x, and then from O to Q is negative 4x minus 3. So we know that those little segments of the diagonal are going to be equal. So we can set these two things equal to each other. Okay, so if I solve this by hand, I'm going to add 4x to both sides, and then I'm going to subtract 67 from both sides. That way this cancels, and then this would be a negative 70, and then I would divide both sides by 14, and x is going to equal a negative 5. But I'm not done. That's what negative 5 equals. This says find the length of the diagonal. So what I can do is I can take O to P and I can plug this in. Okay, so 67 plus 10 times a negative 5. Okay, now that's going to give me just the length from O to P. Which is 17. So I'm going to write that here. OP equals 17. So if I want to know the total length, I can double it or I can add it to itself. Either way, it's going to give me the same amount. So that's 34. Okay, well, let's look at the back now. Finding perimeter. So solve for x, then find the perimeter of the rectangle. So we have this side and this side. Opposite sides are going to be congruent, and then we have this side. So if this one's 4, then this one's going to be 4. So since these two sides have an x, we know they're equal. We know these two sides equal each other, so we can set them equal to each other. Okay, and then we can solve. So for this one, I am just going to do in solve on it so we can get the value. So menu 3(1). 3x plus 18 equals 24 plus 5x, comma x. And so x is going to equal negative 3. Now I need to find this side length. So I can plug that value in. And that gives me a 9. So this side's 9, and that means this side's 9. Now I can just add up all 4 sides. And my perimeter is going to be 26. All right, last little piece here. Angles and diagonals. Find the value of x. Okay, so here's our relationship. We need to find the measure of A to O to D. Okay? So that measurement right there, okay, so this angle right here, we have a straight angle. So since this one is 112, I can do 180 minus 112, and that means this angle here is 68. Okay? I also know sorry guys, I'm just looking at my notes. Okay, so I know that ADO, so this angle, plus DOA, what I just found, is going to add up to 180. Okay, so ADO, that still isn't right. Hang on, give me a sec. Okay, so this angle, I know it's hard to see, is 68 degrees. So that means this angle here, ADO, this one here, and this angle here, they're going to be congruent. They're going to measure the same thing. Okay, so if this one is 7x plus 7, then this one is 7x plus 7. Okay, they measure the same. So remember our rule of triangles. All three angles in a triangle always add up to 180. So if we know this one is 68, then we know these two together equal 112. So we can find the measure of one of those by cutting 112 in half. 112 divided by 2 equals 56. So angle ADO is going to measure 56 degrees. Now we need to find what x is. Okay, so we know that ADO is also equal to 7x plus 7. So we can set those two things equal to each other. So we can do menu 3-1, 7x plus 7 equals 56, and x is going to equal 7. Okay, there's a lot of relationships there, and we will look at a lot of examples of those. Okay, and that's the last bit, so that's it for this set of notes.